Welcome to STM's demo webinar for the RocketBox 2.0. Today, we're going to be focusing on a couple of key things in relation to the RocketBox. First is we're going to go through a full demo of how the machine works and do an actual run for you. In addition to that, we'll walk through some of the components, what they're for, the different variations for different cone sizes. We'll go into a little bit about density software and achieving accurate weights. And then we're going to have a nice open Q&A for everyone where you can sit down and answer any particular questions you have. Throughout the demo, we welcome you to hop into the chat, ask any questions at all. We can tackle them right then and there for you as well, right during the demo, and show you anything in particular that you may be looking to see today. So I'm going to introduce Christopher Mendoza, who is our technical associate here running the demo, running the machine back at home office. Chris here at headquarters, because he's all set up and ready to go. Chris, I'm gonna let you get started. And again, welcome everyone, and thank you so much for joining us today. We're excited to have you.
Heck yeah, just what Jessica said, thank you so much for joining us, guys. We're gonna make this as fun as we possibly can, because while we have pre-roll equipment in front of us, that's gonna make our lives a little bit easier, right? We're gonna check that out a little bit today. I'm actually gonna start us off with a run here just to kind of cut to the chase, and let's see how these cones are actually made with this machine here. And I'll go through a little bit of what the PLC kind of looks like too, and kind of the components in front of you. You may have seen some of the videos already, pictures of this machine, maybe while you're even here, to see a little bit more, and let's just cut to the chase and get those cones rolled. I'm using zigzag cones today, the 109, so we're gonna be shooting for that 1 gram today. Cone selection is key, especially when it comes to running any kind of pre-roll machine in this entire industry. Finding a cone that is very good quality, always has a nice open tip to it, as well as nice crisp paper to it as well, will give you most optimal results possible. So that's why we use them today, right? All right. So from here, I'm gonna put my top tray on. We'll talk a little bit more about the top tray here a little later. That's actually kind of the bread and butter of the machine really too. It sets those fill lines and also too helps us fix any kind of weight issues that we may have. If we're crushing cones, we can always raise it up. There's a lot of different things we can do with this particular device here, which is great. The next thing we're going to do is, bam, give you guys the action view here. Of course, we can, why not? So what we're looking at here is our bottom tray and our top tray inside this loading box here. And basically all I'm going to do is start loading this into our machine here. You can see that, hey, I got my entire tray full of cones. They may be a little bit off from one another, and that's why what we're seeing inside here in our machine, the lift plate is there. It actually evens out all our cones for us here from the ground up, or from the crutch up, excuse me. So you can also see too, hey, yeah, I have a plastic bag in here. What the heck is that about? It's actually a 100-gallon liner right here to keep the entire machine isolated from every single batch to particular products, or maybe just keeping the machine clean so I don't have to work as hard at the end of the day to keep everything nice and sanitized. So definitely recommend utilizing the 100-gallon liner every single time I go to this machine or even the Mini. We're just going to tie these down here really quick. My ambidextrous skills were not with me there at that moment. That is okay. We're just going to move on past that here and then just get the machine going. Now I have my machine already set up and ready to go as far as, I inputted my density, I got all my speeds and everything. So from here, I'm just going to press the go button. And we're going to take a look at how this material fits in here. Material prep, just to go over that, is key too. We want to make sure material flows nicely. It isn't clumped up, isn't too high of a moisture content or anything crazy like that. Reason for that being is because we're going to have a lot of holes in our crutches, things may happen, and the quality of the cone may go down, the work may go up. right, so pretty quick run there. We had that set for about 1:10. Running the machine a little bit aggressive there, but it's a very quick run most of the time when it comes to doing this full tray here.
So, Chris, I'm just going to step in for a minute, give some sales points here. First, just one little note is that the one beautiful thing about the RocketBox 2.0, and it's a silly analogy, but it tends to work quite well, is the RocketBox is very much like an oven, like an appliance, in the sense that it is simply the tool that you can use to create the recipes that you desire. One of those key bullet points and how that works is even when adding material, there's a number of ways you can add material per your preference. For example, you can add it from a bin directly as Chris just did. You can place it into a container that has almost like a pouring spout where you can just sprinkle material on that way instead. Each operator will run the machine in that sense in their own sort of ways. The other beauty is that in terms of settings, which Chris is going to go over shortly, every single machine is going to work the same, but every operator can customize those settings to work for them and create the results that they're looking for. So we're going to go into a little more detail shortly, but first, let's go ahead and take a look at the tray that Chris just produced.
Alrighty, so just trying to give you guys a good view of what happens, what's real. Why do things happen here? Why do we have adjustability with our machine? So we can see here we have a full tray of cones ready to go. Fill lines are actually pretty consistent. We may have a couple here that did not fill in. What happened there? Well, pour method can be a thing too, as well as adjustability of our top tray, making sure we get a good flow of material. The ability to be able to adjust this machine to fix things such as this, or be able to fix things such as our fill lines. Maybe we want them a little bit higher, maybe we want them a little bit lower. We have that ability to do that right here with our top tray, our adjustable top tray right here too. Gives you that edge to be able to say, hey, this didn't work out this time, let's move on to the next step here. Tell the operators this is what needs to be fixed and start moving that production forward. Very important here with any pre-roll machine.
Perfect. And again, just to add, so each tray, and again, if you're using a standard RocketBox 2.0 with the standard tray set, each tray is about 453 pre-rolls at a time. The cycle does typically sit within a 60-second time frame. Again, of course, that is adjustable by the operator. On average, just to account for any potential cones that might have gone in that might have not had an opening, or any clumps of keef that might have come into the tray, typically you're going to see at least a 90% an upfill rate, meaning of the 453 cones, you should have at least 90% of those accurately filled, packed, and weighing within range. We do have different tray configurations. So we have a 453 tray. Again, 453 actually equals the number of grams in a pound. So it's a nice and easy measurement to be able to produce and work with metric and whatnot. We also have a 250 count tray for smaller batches, which is great, especially as you're nearing the end of a batch of a specific strain. And we have a 50 testing tray. The 50 testing tray is fantastic when working with new strains, and that allows you to essentially test out your settings in advance, see what you like best with that strain before you do a full run.
R&D is key here, everybody, too. That's exactly it. Just having that ability to test, do a run and see, okay, what was the best thing that happened here, and what are the things we may need to fix. That R&D is very, very important too. And even so, like those smaller trays, even like Jessica was saying too, maybe we don't need to do a full pound here. Maybe we need to reduce the amount of material that we're utilizing here. Maybe we're at the tail end of the batch. Let's reduce that down a little bit more to a smaller tray. We have that ability to isolate those and run them, keep the quality high. Alrighty, so a little bit heavier than I was going for too. We're looking at like that 1.2 range. I might have some of these trickling down to that 1 gram range. So what do you do in this situation? Why did this happen? A lot of the time I have to look at, well, how did I pour that material onto that machine? And as well as too, making sure my scale actually tears everything out properly here while I'm doing these weights, everybody. So I appreciate you bearing with me on that. There we go. But being able to change basically how we run the machine, how long we run the machine for, these kinds of things can help us adapt, help us change these situations and keep us from having, any issues with the run that we have time and time again. As I take you guys further onto this here, as we kind of do a couple more weights, I'm going to show you the PLC and just kind of get through that a little bit for you here too. The machine has a calculator in it basically to help the user understand really what the material is going to do before anything happens, and we'll go through that here.
Hey, Chris, you might want to tear, just a quick note, you might want to tear one more time. I did see the tear jump from 2.6 to 0.30 to 0.36 on your scale. And
yeah,
that
absolutely.
could be affecting your weights right now.
Yeah, the scale has definitely been bouncing on me a bit here and there, so.
That's more like it. There you go. Yeah, I want to be careful of your scales. Just make sure you're tearing it appropriately. There you go.
Yeah, typically too, just making sure we do have a gold scale on hand, you know, that's going to be key. When you're utilizing a scale, anything like this, you're going to have some variation, something you very much want to watch out for, especially when it comes to pre-roll production. One scale can be different than the next.
If you notice just now, the scale went from 0.2, it was 0.21 up to 0.28. And once it was in that tighter range versus the 0.36, you can see that most of the joints are now right within that 10% variance that they should be. So yeah, just keep an eye on that scale just to be sure that your tear isn't off for any reason. One other pretty significant note, especially for those interested in our atomic closer. So the one main configuration you're looking at now is the standard use of the RocketBox 2.0. The beauty is that we've created a fully modular workflow to where you can start from anything from grinding to filling and packing, weighing and closing, all within a small, compact format. If you are looking at the atomic closer, the key difference here in your production is that as opposed to using one large tray, you're actually going to use 2 mini trays instead. So it looks very similar to the tray in front of you. It's essentially just 2 of those and in a 72 joint configuration. The one thing we like about this too is that you have a little bit more control. You're not adding as much material, per run, which does give you a little more control in the process, but you're able to run 2 trays at a time. Once you remove those trays, you're able to place them right onto your weighing pad or skip that and run right into your atomic closer module. And as you put the tray into the module, what's going to happen is all 72 joints will close within a matter of 40 seconds and be ejected so that you can just take those completed pre-rolls and place them right into packaging. And so each person throughout your workflow is going to get used to their machine. They're going to be set in that one spot, and you can go anywhere from 100 joints a day upwards of 41,000 joints a day and significantly decrease labor in that sense. So depending on the other modules and system you're using is the sort of the configuration of trays that you'll be utilizing moving forward as well. The trays come in a multitude of different sizes to accommodate new industry innovations. So of course we have your standard sizes. We have the 84 millimeter, which is your half-gram tray. In that you can do anywhere from 0.5 up to 0.7. Typically it's a half-gram weight that you're looking to achieve in that tray. We have another tray that is also an industry standard size. It's 98/109 millimeter, meaning you can use a 98 millimeter classic all the way upwards to a 109 millimeter king size cone. Of course, 98 millimeters, less volume in that cone. That's typically meant for 0.7 to 0.75 gram. And then your 109 millimeter is going to be set for a standard 1 gram cone. In addition to that, some of the newer size we've released in the last few months, we now have a Dogwalker tray. So it's a 70-30 millimeter tray that allows you to produce anywhere from 0.25 to 0.4 grams. Dogwalkers are increasing quite a bit in popularity, and so we're seeing a lot of excitement around that size. Separately, we've also released a cigarette/reefer tray. So you can now produce reefer size cones as well as cigarettes in the same machine. There is no need to purchase a separate unit or really do anything drastically different. The nice thing is that all the trays are universal. So you just need to have a different bottom tray, and that's what allows you to produce these different cone sizes. Last but not least, we do typically recommend, again, depending on the configuration and if you are using the automatic closing module, we do recommend having a few different bottom trays. The reason this is key to the workflow in your production is that you can have one tray in one, as I call station number one, where someone is dropping in the papers. Station number two, you have another bottom tray, and that's the one running in the machine itself. And then station number three, of course, would be the trays that are now filled and packed that you have the team pulling out and closing, or simply handing off into the atomic closer module. Either way, multiple trays are really key as they allow you to reduce any sort of bottleneck that you might have in the workflow. So whether you're producing very few joints a day or quite a few joints a day, either way, you're able to produce effectively, efficiently, and reduce any sort of delay in time in getting one tray from one station to another. Thank you so much, Chris. I will bring it back over to you.
Absolutely. All right. So we saw that, hey, we weighed out a ton of joints there. They're looking in a good range. Watch out for your scale if you're talking about industry standard. Make sure you have a gold scale. Second thing here is taking a look at this lift plate like we were talking about too, and looking at this inside of the vibratory plate, very clean after we use that 100-gallon liner. Keep that in mind if you were picking up one of these machines here. Last little thing I'm going to touch base with here with everybody is going to be that PLC screen. This is going to be what we see basically at the end here after I press go. From here, essentially, you're going to be seeing the home screen most of the time when you turn your machine on. We have two different options here. We have the training button and start button. A training button has two options here as well. You can go to the user manual, which every single machine is loaded up with their most current user manual, or can be utilized as an SOP as well too if you guys are looking for a standard for each machine. These are actually have a lot of the data and results that you're going to be looking for as far as components, glossaries on information, and what is the machine composed of and how do we run it, basically the most standard process. The next one's going to be the video list that we have as well too. These are found on our YouTube page, but can also be found right here directly on the machine as well. If somebody's new, if somebody's coming in, they don't know what this part is, they need to go communicate with somebody about something here, or we're really just trying to build out these manuals. Regardless of what you're doing, you still have these videos to always refer back to right here directly on the machine, as well as on your phone, PC, or anything else that you have available to be able to look at those videos. All right. From here too, we're going to be looking at basically what is the density calculator. Essentially with this machine, you may have heard many times that, hey, you can select ranges of cones and you can actually select your percentage of what you're going for. This in reality is a calculator. It helps the operator understand what's going on, but it does not program the machine to do anything automatically. For me, I'm about programmed our machine here. I said to the calculator, hey, I want a 109 cone at a 10% variance. And it tells me I need to be within a density range of 0.107. What does that mean? Basically, what is my material going to do in this cone? How dense is my material from grind? Do we have to grind it fluffier? Do we have to grind it finer? Do we have to run the machine less? This is the kind of stuff that we need to know before we go and start making cones, right? Otherwise, we're going to be shooting in the dark. That's why we have this data right here to help us out. From here, you're also going to see, hey, you can input that density as well too. If it checks out, you're going to get that green check right there and you're looking good. It'll tell you, hey, maybe I'll be outside this range a little bit, 1.007, that kind of thing, right? From here, you're going to see this 0 mark. You're definitely going to see this little kind of hash going through here, and you can run a density test. Now, you can do density tests multiple ways. This one being that you can run it 3 different times in this screen, and you have an opportunity to really get an idea of your material and what it's going to do. Inputting that density, my density here is 0.182, bam, done. Going to next, we can input now finally how the machine is going to run. This is going to change everything for each operator. You can increase the time, you can change your PSI, you can also change your shaker speed. The more we work this machine, the harder we work this machine, the more material we're probably going to pack into a cone. The lighter we work the machine, probably a little bit less, a little bit more of a gentle pack. Depends on how our moisture content is, and it depends on the operation. And finally, that last screen we were talking about too. If you're doing multiple runs and you may get lost, you may have had a great run the other day. You might have had this Bubba Cush that was there about a week ago, and you're like, gosh, lot 223 at Bubba Cush ran great. We're getting lot 224 in at Bubba Cush now. How did we run that last time? How did we cure that? What was our length of time? Well, we can look back 100 different runs here, 100 past runs into our machine to see how was it ran beforehand, what was our density, and what happened on that date. Really handy for figuring out basically what works best for your team. All right. So from there, yeah, go ahead, Jessica.
One other key thing to note is that the density test is really something that you want to start to implement when you're working with a brand new strain. Once you've identified a particular strain, a particular batch of material, you've identified that density, input your settings. At that point, you're really just repeating that run over and over again. The density test is not required for every single run, just when you are working with a brand new material. And the primary goal, of course, aside from actually achieving weight, is really just to ensure that you're starting with the right material that's going to help you achieve the weight in the pack that you desire from the get-go. Thanks, Chris. Go ahead.
Yeah, absolutely, absolutely. So just finishing up, basically we have the resources with this machine to be able to have adjustability, figure out what you need to do before you need to do it, and essentially give you the confidence that you need to be able to run pounds of joints basically throughout the day. That being said, we also have the atomic closer. We also have auto weighing machines coming up. We have a bunch of different stuff that's going to be working in tandem actually with this RocketBox 2.0 model, as well as the mini RocketBox as well. So I would really highly recommend checking these things out. If you have any questions, please contact the salespeople as well as client services. We're always happy to help you out. And I also am very happy to help you out with any troubleshooting questions you may have too if you purchase this machine as well too.
Thank you, Chris.
Does anybody have any questions or anything else like that? Yes, Jessica.
I'm actually just going to run through a couple more things specific to the RocketBox, especially for those that might not be extremely familiar with the equipment. So one of the key things, and actually, Chris, if you can leave that screen on, I'm just going to point out some items in that video. Thank you so much.
Yeah, no problem.
For one, I just want to really quickly note what the different components are, so everyone has an idea of what each item is for in that process. Of course, on your left-hand side, you have the RocketBox 2.0 itself. In the center there, you have your bottom tray. And this is, again, the one that we were mentioning earlier that dictates, what cone size you're able to use in the machine. The bottom tray is also the one that we mentioned you want to have multiple of in order to have a complete workflow and avoid any bottlenecks in your production process. On the right-hand side, you have something called the loading box. This is essentially station number 1, where you're placing your bottom tray inside in order to evenly drop your papers down into the tray itself. The tray that we used earlier, the one that you saw the excess material in, that is called the top tray. You typically only need 1, maybe 2, and that essentially is allowing the material to meter into the paper at a certain height, which helps meter volume, and you really only need it during machine operation itself. So that's essentially your workflow, right? Station 1 is your loading box where you're dropping cones. Station 2 is your rocket box where you're filling and packing the cones. And then station 3 is, of course, going to depend if you have a atomic closer module or if you're closing manually. If you're closing manually, you're going to be using the finishing base, which is simply that white base that you saw under the bottom tray, allowing all the cones to be pushed up to the surface for collection and closing. If you're using the atomic closer and our future and up and coming weighing pad module, then you're simply placing these trays into these other modules and letting them do the work. Any questions, just briefly, in regards to workflow or specific components before we dive into another part of the RocketBox 2.0? Feel free to also hop off your mic or send any questions via chat.
We had a question.
Sure.
For the large tray that holds 453, does that fit in the closer module?
Great question. No, that is the whole purpose behind the 453 tray, is that if you are closing manually, you want to fill and pack as many cones as you can. That way you can hand it off to the closing team, being that, of course, closing is the longest part of the process.
Right.
With the atomic closer, you really don't need such a massive tray, which is why we focus on a much smaller formatted tray. Those are the 72 count trays that you would receive when you purchase the RocketBox with the closer. You are, of course, doing a lot less joints at a time, but the atomic closer is so fast that at that point, you're able to actually pay a little more attention to detail during your RocketBox runs and do smaller batches, especially as you're working with a number of different strains. So
Okay.
if you have
Oh, sorry.
No, go ahead.
With the 72 tray, does it fit the same zigzag 109 king size cones?
They do. The trays are actually, regardless of the configuration, right? Whether you have a 72 count tray, a 250 count tray, or 453 tray, the actual papers going inside, they are going to be universal across the board, meaning every tray has the same size options. So if you have a 109 size option in your 453 tray, that same option would be available in that 72 count tray.
Perfect, thank you.
You're very welcome. So any other questions in regards to components or workflow? Okay, all right, sounds like we're good, perfect. Last but not least, the one thing that we didn't touch on earlier that I do want to certainly walk through on the RocketBox is how it is physically working and what it's doing, and how, of course, that differs from other machines in the market. Typically, as you can see with our unit, there's a lot being produced at a time, and you can see this entire tray being filled. A lot of joints have already been, of course, pulled out, but what you can see is an even pack from the crutch, right, from the bottom all the way to the top. And often an issue that we see in other units is that one gap in a weak neck in that bottom portion of the joint. And a whole huge portion of why that's happening is the mechanism in which the joint is being packed. So, for example, packing the joints by tapping them from below or using straight vibration alone, these tend to cause the material to drop into the cone all at once. And kind of think of it like the game of Tetris. If you drop all your particles or your pieces down at the same time, you're not creating that structural integrity from the bottom up. Now, as opposed to using a straight vibration only, we do have a pneumatic leveling system in our machines that causes us to be able to have that nice structural integrity from the bottom up. The reason is that, or the explanation in a way is, think of almost like a car suspension or an airbag. What it's doing is it's taking all the powerful vibrations from the machine and concentrating them in the area where the joints are sitting. So as opposed to the papers bouncing up and down or being shaken and vibrated in any way, what's actually happening is these vibrations are being concentrated to the point where the material itself is vibrating. So as you pour material on the unit, the material is moving and moving, and not only on the surface, but actually down into the cone. So as the material is moving inside the paper, it's actually becoming more and more snug inside. And so not only able to customize your settings to adjust that pack, but regardless of how you adjust your settings, you are going to find that you will have that structural integrity from top to bottom due to the mechanism of packing. Again, this just ensures a nice solid pack, all the way through. Any questions in relation to, the technology and how it actually is filling and packing these cones? Okay, no, it sounds like we're all good. Awesome. Well, everyone, thank you so much for joining us today. It's been a pleasure having you. Thank you for allowing us to show off the RocketBox 2.0 and give you a brief overview of how the machine works. If you have any questions at all, again, we'll hang back for a few minutes. Feel free to take yourself off of mute, or again, simply message us in the chat here. Otherwise, of course, you can also contact your sales rep from here. We really appreciate your time, and we hope you have a wonderful day and happy holiday. Thank you so much, everyone. Again, we will be hanging back a few minutes just in case there's any questions. Thanks for joining us.